today we're doing a quiz on 7.3. I'm going to briefly talk about how to use a TI calculator to do confidence intervals. And then we're going to start in on hypothesis tests. Today you have due connect math 7174. And then right away tomorrow is due connect math 7.3. I think you should be okay with those ones as long as you remember to use the z-scores that we rounded off in your handouts to 2 decimal places, the way we rounded them. So that should be all right with those ones. Thursday you have your first connect math due on chapter 8, which we're going to cover today. Enough should give you all the stuff you need in order to do that homework that's due on Thursday. And also Excel Lab is due officially due on Thursday. You can turn it in late full credit up to next week. And then Monday, Connect Math 8.3 is going to be due. So this is kind of all in preparation for our next midterm, exam 3, which will be the Monday. I think I told you already. I'm planning on having it the Monday before Thanksgiving, and then we'll take Tuesday off, and you can, enjoy your Thanksgiving vacation. Also, if you score very poorly on exam 1 or 2, or if you score poorly on exam 3, I will, on your lowest exam, if it helps your grade, I am willing to average that exam grade with the final and replace that exam grade with that average. So in other words, say you got a 40% on one of the exams, exam 1 or 2, and say you get a 70% on the final. Then average of 40 and 70 is 55%. I'll change your exam 2 to 55% instead of 40%. Good, if it helps you. All right, so the final exam is harder than most of the individual exams. So, as a heads up. The main reason for that is not that the problems themselves are harder. The problems themselves are actually a little bit easier, but it's cumulative. So it's everything from the beginning of the semester up to now. So a lot of times people forget, kind of some of the things that they did earlier. So you might be a little better shape because, our semester's not as long as a regular semester. Good. Okay. All right. So the last one we did last class, 7.3, is confidence intervals when sigma is unknown. Because remember, how realistic is it that we are trying to estimate our population mean, mu, and we happen to know our population standard deviation? It's not at all realistic. That never happens. So if we don't know what mu is, we're trying to estimate it, then we're not going to know sigma either. So instead of using sigma, our population standard deviation, if we don't have it, what's our best guess for what to use instead of our population standard deviation? Our standard deviation from the sample. Does that make sense, folks? So we'll use S instead. The thing about it, though, is S, especially when your sample size is really small, is bound to be really inaccurate, right? So instead of using z-scores from the z-table, we have to take that into account and use slightly larger numbers from the t-distribution, which are a lot larger if n is really small. But as n gets larger and larger, it gets closer and closer to our z-scores, as we will see in a minute. So this t-table, you need to know how to use it. Right? You should all have one of these. If you don't have one, they're in the back of the room. And how do you figure it out? Well, the first row, the top rows, are to tell you which column you want. So for us, confidence intervals, it's just the top row we care about. So use that top row to figure out what column you want to use. So for a 95% confidence interval, if you plot along the top, it's going to be the third column. So the third column is the column that I want. If, for example, my n is 22, my degrees of freedom is n minus 1. So if my n is 22, my degrees of freedom is 21. So then I slide down this side here until I get to degrees of freedom 21. That tells me what row I want. So I'll slide along that row until I get to the column I want, 2.080. Good. And as we found last class, for a 95% confidence interval, what's my z-score for a 95% confidence interval? 0.96, great. If n is 2, then my t-score is really big. But as n gets larger, you'll see that it gets closer and closer to my z-score. Right, it starts off huge, because if you have a sample size of 2, they can be right on top of each other, right? I mean, their standard deviation might not be at all indicative of what it really should be. So a really large t-score, but as n starts getting larger, t-score drops down and gets closer and closer to 1.96, the actual z-score. Why? Because as your sample gets larger, your S starts becoming closer and closer to what sigma should be. It gets better and better. All right, margin of error. So this is the first thing you're going to do whenever you have a confidence interval for a mean. First, you're going to find your margin of error. It's our critical value times our standard deviation. Right, because when we have our confidence interval, we start off with when we get our best point estimate, our x bar or our p hat, and then we're going to go a certain number of standard deviations this way, a certain number of standard deviations that way. How many? The critical value tells you how many to go, and then you multiply that by what a standard deviation is. That tells you how far back to jump this way, how far forward to jump that way to find your lower or upper limits. The critical value, how many standard deviations we take from the t-table using n minus 1 degrees of freedom, and a standard deviation for a sample mean. Again, remember, harkens back to the central limit theorem. Mean of means, it's going to be s over square root of n. Sigma over square root of n is where it comes from, so s over square root of n. And then you are not done yet. That's just the first step. The second step is taking that error and subtracting it from the mean and adding it to the mean to get your lower and upper limits. Right, so you can either write it as the top way or the bottom way. Either one, they're both totally acceptable. So just make sure you use one of these two forms. All right. So again, do your steps. First, make sure your sample is either normally distributed or n is at least 30. Pretty much, I'm always going to give you what's normally distributed in less than 30 because otherwise it's not very interesting. And then, using n minus 1 degrees of freedom, find your critical value. All the critical values in this class, I'm going to have you look it up on a table. So whether it's a z-table, a t-table, whether it's going to be for a chi-square table and later on, what you'll notice is, actually on your sheet, this is your t-table, but the very bottom row, we talked about this last class, is your z-scores. So this bottom row really is your z-table. I told you could write in there if you wanted to, z-table just for this bottom row. That helps you. So that's your z-table, and all the rows above, that's essentially your t-table. So hang on to this, you're going to need it for your next exam and for the final. So second step, right? Find your critical value. Again, where do you find the critical values? Look them up in a table. Then find your margin of error, and then subtract that error from the mean and add it to the mean to find your confidence interval. And then last, round the confidence interval to 3/6, or like I said before, round to the same number of decimal places that's in your mean or your standard deviation. Okay, so here is your quiz. What's sample of 14? What's 14? Yep, that's my n. Showed the average of the community times was 33 minutes. Average, that's my x bar, perfect. 33.2. Nice. And then a standard deviation of 8.3, that's my s. All right, so if my n is 14, what's my degrees of freedom? 13. It's n minus 1. My critical value, I looked that up on my table, 95% confidence interval. So it's going to be the third column we're going to use for that. I'm going to use the third column. And then my degrees of freedom is 13. So confidence interval, 95%, third column. And then we're going to slide down to where degrees of freedom is 13. Right, 14 minus 1. And you'll find it is 2.106. 2.160, sorry, 2.160. Then, should have some milk here, my bad. Then we're going to find our error. My error is equal to my critical value, 2.160 times s, which is 8.3 over square root of n, square root of 14. And what did folks get for their error? 4.71? 9. Perfect. 4.79. Terrific. I'm not done yet, though. My last step is going to be to find my error minus, sorry, my x bar minus my error, comma x bar plus my error, right? My actual interval. So it's going to be, what's my 33.2 minus 4.79, comma 33.2 plus 4.79, and you'll end up with minus 5, 28.41,
Yeah.
comma 37.94. And then, how many decimal places does my data have?
1.
Oh, sorry, is this a 9?
Yeah, it's
That's a 9, sorry, 9. How many decimal places does my data have?
2.
My actual data?
1.
1. So look at my x bar and my s. They all have one decimal place. 8.3. Everybody on board? Not 8.32, 8.3. So they all have one decimal place. So I should have this match it. So I'm going to round to one decimal place. So if I round to one decimal place, I'll get 28.4. And 30. If I round this off, I'll end up with 38.0. If you round to two decimal places, I'm not going to mark you off in your homework. On your exam. It's not that big a deal. But I just thought, technically, that's probably the ideal way of doing it, just so we're on board with that. Okay. Also, you might want to take a picture of this or write down your notes. How do you find, if you have a confidence interval, how do you find your x bar or your best point estimate and your error? Well, I found my lower and upper limits, my confidence interval, by taking my point estimate and subtracting the mean, point estimate and adding the mean. That means that if I average them smack dab in the middle, I should find my x bar or my p hat, depending on what's proportion or mean. So how do you find the x bar? You take the lower and upper limits and you average them. You add them up, divide by 2, because there's 2 of them. The error, we figured out before also that, so I subtract an e to get to the lower limit, I add e to get to the upper limit, so that means they're separated by 2e. So if I find the difference between them, the upper limit minus lower limit, that's 2e. Divided by 2, I get e. You might find this handy, you may not, I don't know. I think you might have a homework problem on them. And the last thing we talked about was finding the appropriate distribution. So on your notes, the very, very last bottom thing on your chapter 7 notes, so the back page, is this. The top one, you should cross that out. Why? Because it's unrealistic. It never happens in real life that we happen to know sigma, but we don't know mu. So cross that top one out on your notes. And then for the t distribution, if it's a mean, then remember mean Mr. T. Mr. T is really mean looking. He's not really mean, but he looks mean. So mean Mr. T, mean t distribution. Everybody on board? Mean Mr. T, mean t distribution. For if it's a proportion, you have p hat, use a z distribution. Easy peasy. Proportion, p, z distribution. PZ, easy peasy. The other question is, how do I know if my problem is a mean problem or if it is a proportion problem? Well, the easiest way of telling is a mean problem will always, always have the words mean, average, and also standard deviation in it. So these ones will say mean or average in the problem and standard deviation. So the problem in our quiz, if we look back at our quiz, so you should probably write notes like that in there. Make sure you have that in there. Make sure you talk about the mean Mr. T if that's not in your notes already, because you're going to want that. Here, how do I know this is a mean and not a proportion? Talk to your neighbors, 15 seconds. How do I know this is a mean and not a proportion?
Yeah, it also says mean.
How do I know? Anybody?
Average.
It says average. Average is another word for mean. It says average. Also, what else does it say in there? That's another clue? Standard deviation. Good. So, there you have it. And then also at the end it says of the true mean. So there's the word mean also. It's all in there. All right, good. So let me talk about using 83 or 84 to do stuff. Again, we don't care about that first one. Let me show you. Show everybody. So here's my calculator. Turn it on. If I go to stat, test, see all those ones are z-test, t-test, two samples, z-test. See how they all say test at the end? Let's scroll down a little bit. These guys say interval, interval, int at the end. Okay, so quick question. Which one do you think is for a confidence interval? Michaela, do you think it's the one that ends in test or the ones that ends in interval? So one of them is going to be for hypothesis tests. One's going to be for confidence intervals. Which one do you think is going to be for confidence intervals? Ones that ends in test or the ones that ends in the ones that end in int? Talk to your neighbors. 15 seconds. Go. Okay. If you said interval, then you would be correct. The ones that end in interval are the ones that are for confidence intervals. The ones that end in test are for hypothesis tests. So, my options for intervals are Z interval. That's the one you never use because that is the one where you happen to know your sigma, but you don't know your mu, so it's ridiculous and unrealistic. For means, this one says T interval. That's the one you're going to use. I'm going to go ahead and enter that one. So what was our quiz problem? It was, first of all, data. Do I have the actual data, like all the actual raw numbers? No, I don't have them. If I did, I'd put them into list 1. See where it says list L1? I'd put all my raw data into list 1, and then it would find all the stuff for me. But instead, I don't. I'm going to go to stats next door. So I'm going to go over the next arrow over to stat. And then see when I hit enter, it changes. So what was my mean? What's my x bar in this problem? 3.2, perfect. What was my s? 8.3?
Yeah, 8.
And then what was my n? 14. Great. What was my confidence level? 95. So 0.95. 0.95. Calculate. Just a little out. Bam, there it is. 28.4, 37.99, so 38.0. Good? Right? Now, here's the deal. On the exam for chapter 7, I'm going to make you find the margin of error and show me the numbers you computed. So this is just more of a checking than anything else, because it's not that hard to compute all this stuff. And I'm going to make you find the margin of error anyways. But it is a good way of double checking things quickly and easily. If your homework gets really annoying, then you should probably feel free to use it. And then stat and test. Now for the proportions, Z and T intervals are for the means. So see where it says 1 proportion Z interval? The proportions So we only have one proportion so far. So it's going to be one proportion z interval. Because remember proportions, PZ, easy peasy, proportion z table. So proportions use the z table, and we only have one in chapter 7. So one proportion, z interval is what we want. And then bust out, if anybody has your quiz from last class, you can take a look at it. And we'll see, let's see, it was nutrition found in a sample of 80 families, 25% indicated they ate fruit at least 3 times a week. Okay, so my p hat is 25%. Here's the deal. It doesn't give me a spot to put p hat. It wants x. So remember sometimes you'll be given the percentage, p hat, and sometimes you'll be given x, and you gotta find p hat from x. P hat is x over n. Here, they want n. Or sorry, they want n, but they also want x. They want x and n so they can calculate it for themselves. So that means I have to figure out what my n was. So 25% of 80, that means multiply, so 0.25 times 80 is 20 families. So my x would be 20. My n is 80. My confidence level was 99%, so I'll go down to confidence level, I'll put in 0.99, calculate, and there we go. So if you do have your quiz handy, you'll see the confidence interval was 0.125 to 0.375. Okay, so this makes sense and matches up with that. So that is how to use those. Again, this one we don't use. And then this is the one for proportions. Remember for the proportions, drew that p hat is equal to x over n. Or if you need the x and you have the p hat, x is equal to n times p hat. Good. All right. All right. So then Nathan, a hypothesis test is a test to see if your sample is unusual or not. All right. So this is what we've been doing. We introduced it last class. Go ahead and pause this for a minute, and then I'll.